Hello and welcome everybody. This video is about the tidyverse package. The tidyverse package is a meta package, which means it includes many other packages. For example, the very successful ggplot2 package for visualization and the deployer, tidyr, readr and many other packages. In this video we will only focus on the most three important commands in the tidyverse package. They come from the deployr package and they are select to select columns, filter to filter the observations, and mutate to create new columns and calculate them from other columns. At the end of the video I will briefly show you how piping works. If you want to have a comprehensive overview about the tidyverse package, I recommend Hadley Wickham's book R for Data Science. It is very comprehensive and Hadley Wickham is the main author of the tidyverse package. In order to follow along for this video, you need to install the tidyverse package. If you don't know how to install a package or if you need a refresher, here's a video link how to install and to load the tidyverse package. So let's start. To understand the commands select, filter and mutate, and later on understand how we can connect these commands, you need to understand the structure of R commands. An R command has a name, like most other commands, followed by open and closing parentheses. Inside the parentheses, there are arguments. They provide more information to the command. And the first argument, at least in tidyverse, is always the data argument. And it is followed by other arguments that provide more information. Let us work with an example. I installed the tidyverse already. Now I load it with a library command. I also load the Rio package that allows me to load data directly from the internet. In this case, I load the Titanic data set and store it in data Titanic. If you look at the data set, you can see for each of the passengers, it has a survived 1 if the passenger survived and a survived 0 if the passenger did not survive. The data set also has some columns that we simply don't need. So here is where the select command comes into play. I go back to my scripting window and I will select only those variables that I really need. I could use the select command to overwrite data Titanic, but it is never a good idea to overwrite data frames. Sooner or later it will get you into trouble. So I create a new data frame, call it data narrow. Here's my select command. First argument is the data command, and it assigns data Titanic to the data command. That is the data the select command will work on. And I type the variables here separated by comma that I want: survived, sex, siblings, spouses aboard, and parents aboard. Then I execute my command, my select command, and I have now a narrower data set with less data in it. Often I want to analyze two different groups, like here, males and females. In that case, it actually makes sense to create two different data sets. I do this here and I use the filter command. Again, I save the results in a new data frame. The filter command operates on the data from data narrow, what I defined here. And now comes the filter criterion, and it says sex equals female. That means I get only the female observation. Please note I use double equal signs here to distinguish this condition sex equals female from an assignment. This is very common in other programming languages too, and it is especially common in database languages like SQL. I also like to know with how many family members our female passengers traveled with. For that, I would have to add the siblings and spouses aboard and the parents and children aboard. And I can use the mutate command for it. Again, I save the results in a new data frame. I call it data female final. And what you can see is I operate on the previous data set here, and I create a new column, a new variable that is siblings, spouses aboard, plus parents and children on board. And you can see here I have a comma, so I'm not done. I want to show you a trick, because I don't need the variable siblings and spouses aboard or parents and children aboard anymore. They just bloat my data set. So what I do, I extend the mutate command with new variables. And the new variables is siblings and spouses aboard, which is my old variable, but now I assign null to it. I assign nothing to it, and the variable will disappear. And I do the same for parents and children aboard. I assign null to it, and the variable will disappear. When I execute the code here, I can see that this is exactly what happened. If I click on data female final, you can see I have a data frame that has only survived and sex and the family count, and it has only female passengers in it. I could now copy and paste the code and change it to generate the data frames for the male passengers. But before I do that, I want to point out a disadvantage. By not overwriting data frames, I created a lot of intermediate data frames. And while this is not a big problem here, if your code gets more complex, it might turn into a problem of readability for your code. I can solve that problem by using the piping operator. The piping operator always must be at the end of a code line. You can add it with Ctrl-Shift-M. An alternative for this symbol is this one, which is also a piping operator. Both of them, for all practical purpose, act the same. So I use the more modern one here. And now what happens is the output of the select command gets pushed through the piping operator into the data argument of the next command. I don't need to specify the data argument here because the output will be pushed to the filter command automatically, and I do not need the intermediate data frame. I can add a few blanks here to make the code easier to read. I add a new piping operator here and connect it to the mutate command. And then obviously I do not need the data argument in the mutate command. I change my name here, data female final. And when I delete all my data frames here and re-execute the code, you can see here is my data frame with the same result than before, but I do not have all these intermediate data frames anymore. Now I can copy and paste my code to generate the male data set. I make a few adjustments here. And here is my data male code. Looks exactly like the other one, except that now only male records are in this data frame. That's it for the 3 commands from the tidyverse, but after we did all this work, we want to see the analytical results. We want to see if women traveled with more family members than men, and if women had a better survival chance than men. I prepared the code here already. I take the mean family count from the data frame female final and do the same thing for the male family count from the other data frame. And then I can print the results, and I see that women traveled in average with more family members than men. I did the same for the survival rate. I took the survival rate for the female passengers as a mean from the female data frame, did the same from the male data frame, and here's the result females had a survival chance of 74%, while male had only a survival chance of about 20%. I encourage you to learn more about the tidyverse, but after this video, you should be ready to start with the tidyverse, and with these 3 commands, you probably can cover about 60 to 70% of all applications. I hope you enjoyed the video. Happy analytics!